Hello guys, welcome to learning microcontrollers. In this video I will show you what is a microcontroller. We are making tutorials on microcontrollers long since 2019, but today I realized that I had never taught anyone that what is a microcontroller. So today in this video I will tell you what is a microcontroller. People ask this question that what is a microcontroller, why I should learn it. So now let me tell you. So guys, see, this is a normal personal computer. We all are familiar with this, right? You know this is a computer. All of us know this is a computer. You can connect various type of like webcams, like Wi-Fi devices, like Bluetooth devices, like many devices that comes in a USB port. You just plug it into a computer and install the driver, and here you go, it's working. They are peripheral devices which work with this. And then you have these devices. These are like input devices, see? It has a keyboard and a mouse. With keyboard you enter things, with mouse you simply drag the pointer on the screen to select various things on the GUI, and this is our input devices. Now guys, this over here, this tower type box, or it comes in the desktop type box. Nowadays compact PCs are also available, and even more than that, USB type PCs are even available, but they all do the same. You like just connect it, and then you connect your keyboard mouse into it, and then you connect the monitor into it. A bigger monitor, doesn't matter how much big the monitor is, it only has a small port. You just plug it into it and here you go, boom. And so guys, this is like the main computer is here, rest are just devices you connect with it. Now what is inside this box called computer? We have a CPU, then a storage device, hard disk, SSD, whatever it is, then we have RAM, then ROM on the motherboard and other devices. Then input output ports, like input output ports allow us to connect the this keyboard, mouse, this LCD or other USB devices, peripheral devices like webcam, like other you have speakers, etc. They all can be connected using these input output ports at the back. This might be the USB, might be the old printer socket, might be the serial socket, whatever the socket or the port you have, they are the input output ports. Then inside this you have the motherboard, and on the motherboard you have various internal architecture features like comparators, timer counters. They are not to be mentioned, but I am just mentioning them because I am talking in reference to a microcontroller. And then you have buses, like you first connect a hard drive inside this box, then you use a SATA cable, or for the SSD a USB cable, or sometimes there are other type of now ports also available. You just connect them onto your motherboard to make them work. Those are buses, like they are serial buses, data buses, address buses, and SATA, IDE, and then you have various other buses going to various components between the motherboard components as well, like I2C, SPI as well. They are available here inside this box. So all of this are a lot of features which I will not mention here, but the main features like CPU, storage, RAM, ROM, input output ports and buses, they are inside this. Now this over here is then our output device. This is an LCD. We may use the output device as a projector as well. Just you need to plug in the DVI cable or HDMI cable, whatever it comes with. And some motherboards have directly the DVI, some don't have DVI. You just use a converter, or some new motherboards have HDMI directly, and then you just directly plug it in. That's all. Then guys, these, like this computer, it means that this system over here has the capacity that it can use ports to connect various other peripheral devices as well. So then we can use an output device like a monitor to display the results, and then a keyboard or a mouse or other type of input devices like joystick, etc. to give the signals. So now let me talk about a microcontroller. Now this is a microcontroller. It's a PIC16F877A. I have a lot of lectures on it. Now guys, what it is, see, inside this you have a CPU which has an ALU and CU, just like the same in that box. This box over here has also a CPU. So this microcontroller inside it is also having a CPU. So it's just like that box over there. It has a CPU, then it have a built-in storage but that is big. It has a big hard drive. It has a small storage embedded on a small chip which you cannot see even with the naked eye. So it is a small computer. Like now it also have a built-in RAM, built-in ROM, built-in input output ports. Just like when you go to buy a computer, you ask them how much RAM it has, how much storage it has, what type of CPU it has. But there you can change the storage. You tell him, no, remove the 100 GB hard drive and replace it with the 1 tera hard drive. I want the SSD, not the normal hard drive. But in this case, this is fixed. You cannot change these specs. Like for the CPU, you have a CPU which can process up to 5 MIPS. Then you have the storage that is 14 KB. Then you have the RAM that is limited to 2 KB, 4 KB, whatever it is. Then you have ROM, that is also limited. Input output ports are also fixed. But the good thing is, just like in the normal computer, you can connect keyboard, mouse, whatever the input mouse you want, and then whatever the peripheral device you want, like you want to connect a camera, like you want to connect a speaker, whatever you want to connect, or you can input from a sensor or a module, something like that. You can do that. Similarly, here too, you can do the same using this port. There are tons of electronics available in the market which you can connect with this microcontroller using the ports available. These ports will allow you to connect LCDs, touch screens, and various other input output devices like sensor modules, etc. found in the market with this. So this is the same concept. Now this also have built-in comparators, some have timers, counters, some have buses, and they are also variable. Like in different microcontrollers, you have different amount of comparators, different amount of timers and counters and ADC ports, etc. PWM ports, they all come in this input output ports. Now guys, now if you compare this with the previous slide what I showed you about the computer is exactly the same. So in short, this microcontroller is a embedded computer. Like it's a very small computer which, when you are making a washing machine, you cannot place that computer inside it. So they developed this small computer. Now you have limited functionality to just program a washing machine. This is also programmable like a computer. Unlike other ICs, DLD ICs, AND gate, OR gate, NOR gate found in the market, microcontroller has a capacity to be reprogrammed. Just like a normal computer, you just reinstall a software and boom, here you go, it has become something else. Here too, like if you reprogram it, it becomes something else. Now guys, this over here are the output devices. Like you easily find the LM016 LCD in the market. Touch screens like NextGen, Deviant, Stone, they can be connected with this microcontroller. Even your ordinary monitor can be connected with this if you know how to program it. Now guys, it also have output devices like 7-segment displays. They are used a lot. Then you also send the data using RS485 USB to TTL devices to computer or laptop for debugging, etc., or RS232 or RS422. A lot of protocols are available in the market. You use this protocol with the UART port of your serial interface port of your microcontroller to connect with a computer, laptop, or whatever you want, or between the microcontrollers, etc., between the PLC and a microcontroller, etc. So they are also like, they act as both as input or output devices. They are basically protocols and you can use them for both. Then you have Bluetooth and Wi-Fi modules. They can also be used for both, also for sending the data to a mobile phone or receiving the data or to any other device. Then guys, for the input devices, you have a lot of lists. Like for a normal computer, you have a lot of input devices like joystick, keyboard, mouse. There are tons of type of keyboard. Then like pads nowadays available, touch pads, etc. Whatever you want, you can buy for the input device and plug it in the USB port, install the driver, boom, here you go. Same happens here. You buy an input device like a button keyboard, then you program the microcontroller, boom, here you go. Then RS485 USB TTL device, as I told you, it can be used for both input output. Similarly, Bluetooth and Wi-Fi modules. Then you can also use the sensors to input the data to the microcontroller using ADC channels or whatever the output form of the sensor is. Then modules are also available like PWM modules and various other type of modules, sensor modules, which allow you to use them as input devices for your microcontroller. So now if you compare this with the previous slide, you will come to know that this microcontroller is an embedded computer, a small computer. Now guys, here you go. Now let me give you a brief description of this microcontroller. Now this is a microcontroller. Inside it you have a CPU like in an ordinary computer, and inside the CPU you have ALU, CU and some data buses, registers, etc., just like in a normal computer. Now guys, this over here you have your ports, and ports includes UART, serial ports, SPI, GPIO, general purpose input output like your normal digital input output pins, PWM pulse width modulation ports, CAN. In new microcontrollers, in the newer versions, CAN is available, while in the ordinary old microcontroller you may not find the CAN. Like in PIC16F877A, you don't have directly the CAN port. Then you have I2C, ADC ports, etc. You have all of these ports in a microcontroller. So these ports can be used to connect any sort of input output device like a LCD, like a keypad for the input, an LCD for the output, like a LM35 temperature sensor for the input, then showing the data on a 7-segment display on the output. You will use these ports to do all that. Now behind each port, like for the ADC port, for the sensor, like you want to connect a sensor, then you have an ADC module in the architecture of the microcontroller. So the ADC module will perform all the necessary operations for this port to operate, and then its output will come through this port. You don't have to worry about the module, it is inside the architecture. Only you care about is the pins, how many ADC pins you have and what is the resolution, etc., and that further specs like resolution etc. goes to this ADC module that is built in the microcontroller. Similarly, for the other specs, you also have built-in timers. Then you access the timer through the ports. Some pins have special features like it is doing two stuffs. Like one, it can act as a digital input output pin. Then it can also be used as a timer. So you also have built-in timer modules. Now these are the modules. Now counters, you have the counter modules as well. Like you can turn the timer as a counter. So timer oblique counter is a better way to demonstrate this. And then you have pulse width modulation module in a microcontroller. In some you have it, in some you don't, but microcontroller do support this. This allows you to like control the speed of motors etc. Like more peripheral devices like motor, you just use a transistor and a motor, then you send commands of the PWM. This will allow you to control the speed of the motor, or in short it will allow you to interface the motor with a microcontroller. Just like if you want to interface a motor with a computer, you will use the same module in some form. Now then you have a RAM just like in a normal computer, then you have ROM, then you have buses which will connect all of these together, and then the output will be sent to the ports. So each of these port has a module behind it which works. So in this way your microcontroller in short is just a computer with limited functionality for an embedded job. Now let's go to the internet. I show you something on the Google. You will see, okay, this is, let me zoom in so you guys can see better. Let me turn on the magnifier. Now take a look here. What I show you is that I show you the card of a washing machine, PCB card of, now these PCB cards you find in your washing machine etc. Take a look here. I hope you guys can see. I think it's a low quality image, so you open some other. Now see, these cards you can find in the market. They have displays on it, and then they have onboard electronics as well, as you can see. See, you can see that you have a lot of electronics on it. Now if you go for these are the older machines. Like older machines had digital input output based cards, and then you now get the modern machine, PCB card of Wi-Fi washing machine. Now I write this. Now take a look here. Now the newer machines, I think it's very low quality image. Okay, I just click, I hope, and then I try to zoom in. Now these are the washing. Now what I wrote here is that I added that Wi-Fi washing machine means the latest machines available in the market. Now see here, you can see, I think I can zoom in. Okay, I just click on it. Now take a look here. It has a microcontroller on it. See, a microcontroller connected to various relays and other ICs working in collaboration with this microcontroller. Now these are the ports, just they have used a PCB. This is a microcontroller here. Now same will apply to your other devices as well, like your AC, fridges. See here, you also have these chips on it. Okay, let me show you PCB card of AC, so split AC, or I call it DC inverter, the latest found in the market. Now take a look here. For the card of these DC inverters, you will find various amount of these chips. Now you can see this black chip over here. In this photo you can see there is a black chip. This is a microcontroller controlling the operations of this. Now in the washing machine you can see that it is controlling the motor and other stuff. Here it is doing the different tasks like reading as input from the sensor, the temperature is equal, then tripping the compressor and other stuff. You can see that in all of these you will find this black chip. See, this is a microcontroller. See, it's an embedded computer. Now this has been installed here because if we didn't use the embedded microcontroller, then we have to use the whole computer, and that's too expensive. Now take a look. In all of these cards you will find these chips. See, there it's the chip. Now now write the name of any modern device that you have, you will find these type of chip. PCB card of I will call smart TV. Now see, in the PCB card of smart TV you found this black chip. See, this is the same microcontroller over here. See, in all of these you will find this black chips, either in the SMD form or in the other form. These are called microcontrollers. They are like controlling the operation. In whatever chip you want, they might have the same model, like PIC16F877A can do all of these tasks, just you have to reprogram it. Like here you can see a programmable chip. See, in all of these you will find, see, here you also have a microcontroller on this card as well. So that's how these things work nowadays. Now what I show you is that I show you something called specs of a microcontroller, like specs of 80 mega 328p. This is the microcontroller you found on the Arduino board. Now let me show you the spec sheet of this microcontroller. 80 mega 328p is found on the Arduino boards, either in the SMD form or in the DIP form. Now let me show you something about this. Okay, I think here I will get the specs. Okay, here you go. Now take a look here. Like you go and buy a normal PC in the market, it shows you that this is Intel Core i7 74430, had this much hard disk, this much RAM, this much this much that. Now for the microcontroller, see, it's also a computer, but a small computer. See, it says it's an AVR microcontroller, 8-bit architecture, like you get the 64-bit for the window, and for the normal hardware computer it can support a crystal of 20 megahertz, while in case of a computer it is like up to 3.6 gigahertz and like 3600 megahertz with multi cores, like 12 threads, 4 cores, 6 cores, 8 cores, depends upon whichever you have. But this is an embedded computer designed for small applications like washing machine, TV cards, ACs, etc. So it have very small clock, only the one needed. So number of pins, now these are the input output pins where you will connect your additional devices. Like if you want the LCD to be a touch, then you will connect the touch LCD. If you want the normal LCD, connect the normal LCD. If you want the input to be given through a keypad, you connect the keypad. If you want to use a Bluetooth device, just add a Bluetooth module using these pins. Now this will allow you to access the modules as shown in the presentation, like ADC module built in the architecture of the PIC, or the PWM module, whichever module you want. Now program memory size just 32 KB, but to be honest, this program memory is also limited in the normal computer motherboard. The one you use is a storage memory, bulk storage, while this memory is also limited in a computer as well. So in a microcontroller is 32 KB for the 80 mega 328p. And for the now take a look at it, is a flash type of programming. Now this is reprogramming feature. Then EEPROM, like you can reprogram it. RAM size 2K into 8, like it's like 2 KB of RAM, while in a computer you have 16 GB, 32 GB. Then this is the pins, how many pins it have. It will allow you to see the architecture or the data sheet of this microcontroller. Let me show you the data sheet as well. Okay, 80 mega 328p pin layout, not the data sheet. We just go for the, now see this same microcontroller, this is 80 mega 328 in the SMD package, having its ports etc. Now it's here in the DIP package. See, this is a DIP package of the same microcontroller. Okay, let me zoom it using this. Now take a look here. See, here you can see a lot of features as well as shown in the presentation. TX and RX pin. See, it can act as a digital input output, also the TX RX, because it's a UART port. Then you have voltage PWM, C, PWM pin, PD3. It can be used as a normal pin or a PD, or you can call it a UART port. Then you have crystal port, like you will connect your external crystal here. Then you have all the features as shown, like PWM. You have access these modules using the programming using these pins. Whenever you want to connect a device supporting PWM, like you want to control the speed of a motor, then you will connect it to these, any of these pins supporting PWM. Then you can see the ADC pins, analog pins. You can access the analog module built inside this microcontroller using these pins. Now whichever microcontroller you have, you will find these features. And this is how you are going to access them. First you will see, do your microcontroller have the feature? And once you know it have the feature, then you will use these ports to access this module. So guys, this is it. If you guys have any questions, you can ask me in the comment section. Thank you very much for your time guys, and have a nice day.